Let me get my recording. So I'm gonna be using the Structy platform to practice some coding stuff. All right, so after we read the test, so write a function greet that takes in a string argument s and return the string as. So okay, yeah, let me do that. So it takes in a string. This is the function greet, takes in the string s, and basically, so we're writing a function that takes in there, return the test to check. So basically, whatever we passed into that function, whatever parameter. So we're writing a function just checking if my audio is coming out. Is the screen captured? All right, I'll just check. I want to see if my audio is coming up. Okay, so it's giving me the audio. Let's see if my audio is coming up. And not just go to everything, just like that. So as I read through the numbers that I'm providing it, so nums here is the array I'm providing as my input. So basically, I'm iterating through the lists. I'm through the array given here, and then so I'm iterating through this array nums, right? And then making a check if the number is greater than largest number, then largest number equals to the number, and then it returns the largest number. Okay, let's run it. Let's keep doing that. Okay, so it says it's coming. I need to inform me, so let me just, if I can't use negative infinity, I could use nums 0. Okay, so let me just check a solution. So I'll check a solution just to see before going on.
It's true, so I should replace that. Only negative numbers, right? It's not, so our space complexity here is going to be a really straightforward solution, but I want to be in those walkthrough videos.
Oh, I gotta put floats, because I can just take it then. Okay. Sometimes you just confuse it. All right. So we'll go to the next one. Writing. Just playing around. I'm coming. All right, so write a function is prime that takes in, let's try to see. Write a function is prime that takes in a number as an argument. Okay. The function should return a boolean indicating whether or not it's prime, so whatever number we are giving it, it returns it whether it's boolean or not. Okay, return a boolean whether or not the given number is prime. The prime number is a number that is only divisible by two distinct number, one on itself. For example, 7 is a prime number because it's only divisible by one on itself. Okay, so a number is prime. If to be able to do that, I need to be able to think about modulus, right? If the number modulo 1, I mean modulo 2 is actually okay, that makes sense. Alrighty. So I can do this right now. So if a number is prime, if it's divisible by 1 on itself, alrighty. So how do we go about solving this, right? To check if a number is prime, if the number is divisible by itself. So I have to make a check to say that if the number n so we do the indentation, right? If the number is less than 2, we return false. Okay, it won't take me data. All right. So the next thing I want to check for in range. So I'm starting from 2, right? To the floor, the lower division, right? Of what? Square root. So I have to import from my okay, since I'm using floor square, let's go math square root. So I'm gonna take square root of the number n, right? Plus 1. If the number n equal to 0, that is if that number, if the number n, if modulo, so the way modulo works is modulo is like it's giving us the remainder. Come on now, bro. So I have to come outside the loop, right? If I did not come outside the loop, it's gonna be a wrong answer. Alright. Okay, we passed it. So we passed all the different test cases. So these are the different test cases. Is prime, 2 is prime, 3 is prime, 4 is prime, 5 is prime, 6 is not prime. Sorry, 4 is not prime. Alright, 8 is false, 25 is false. So they'll give you different test cases. And until we pass the test cases, before we are confident that we are in the right. Okay. We'll continue to move forward. So we are using Structy platform to practice better than refresh data structures and algorithm. Come on now. Alright, we'll move on. Alrighty. So we'll get to arrays and strings.
Hey programmers, in the upcoming module I want to explore some array and string problems. What I have in store is some of the key patterns that you're going to see time and time again throughout the course. In particular for strings, I want to show us the two-pointer strategy, as well as how we can utilize a hash map to improve the efficiency of our array and string algorithms, as well as using a hash set. And what's great about these data structures is they're going to be useful in also other topics that are not just arrays and strings. So let's jump right in.
Alright, Structy. We're jumping right in. Oh man. So that's big O notation to tell us the
Algorithms, and well, it's really the best way to translate power here in the exponent divided by 2 one more time gives me any exponential is going to be worse than any polynomial.
alrighty. Continue the practice. Write a function anagrams that takes in two strings. Okay, it takes in two strings as arguments. The function should return a boolean. So a boolean is either false or true, right? So a function should return a boolean indicating whether or not the strings are anagrams. Anagrams are strings that contain the same characters but in any order. So for example, when we look at restful, so there are different, so rests are 1R, 1E, 1S, 1T, 1F, right? So it's a true. Cats and talks is not an anagram. So what are the strategies to approach this problem, right? So we want to just understand that. Look, let me see his approach just to understand. Yeah, so we're having a counter.
Anagrams. Anagrams are strings that contain the same characters but in any order. And false, right? They are not character within the answer here would be to return true. Restful and fluster contain the same characters just in a different order. Let's take a look at another example. let's say I gave you these two strings of cats and talks. The answer here would be to return false, right? They are not anagrams. Although they share some characters like C, T, and S, cats has an A and talks has an O, and because of that one difference, they are not anagrams, so I return false. Cool. So how can we go about attacking this one? Let's come up with...
Alrighty, let's go back here. Give me a minute. Gonna take a break. Alright. So let's say I want to use dictionaries. I can have a helper function, right? That does the counting for me. Okay, so let me do so basically what this is doing is that I'm going to be going through each character. So this is iterating through each character in S, okay, and then makes a check. So this is an empty dictionary. So it makes a check if my character is not in count. Okay, or not. So it's an if statement. If my character done, it's showing that it's at that point 0, but we need to then update the counts. Count of the character plus equal 1. Let me just take it. Let me use this to make this make sense. All right. So that updates it, right? But then I need to return contexts. Then basically, now I'm going to now call that character count. Function I'm gonna call it. Here you go. Alrighty. So it makes that check. And then once I make that check, alrighty. Let's see. So it's going to return character counter of S1. It returns if it is equal to the character count of S2, basically, right? So we make that return. So it's if the character counter of S1 is equal to character of S2. If this is true, it will let us know. Because basically my return, it says the function should return a boolean, indicate whether or not the strings are anagram. So this makes the check. Basically, once this does the check to see the character count and then gives us this character dict, then we can use that to test and see if we are right. Okay, let's run the test and see. Okay, I'm good. So that makes the check for us. So there's another one. Let me check the guy's solution. Okay. Okay, and then that's okay. That makes sense. All right. So write a function that does the most frequent counts. Okay. Write a function most frequent count that takes in a string, right, as an argument. The function should return the most frequent character of the string. If there are ties, return the character that appears earliest. Wow. You can assume the input string is not empty. So most frequent character bookkeeper, he appears the most. So it has to have a way of actually counting, right? It has to have a way of counting each of these, right? So I need a counter. So let me say my counter is empty our dictionary. So I'm using make it an empty dictionary to be able to register the counter. So I then say for character in S, I iterate through the characters in S, right? And then I say that if card not in counter, if the character is not in counter, just like I did before, I'm going to say the counter of the character at that point is equal to 0, right? If it is not there, but then I update it, right? Right, counter of this thing, okay, plus equal to 1. So I'm increasing it. Basically, this whole thing is checking So I'm iterating through my counter. No, I'm iterating through S and checking. Iterating through S and checking if the so then the next check would be that I've already found the character I'm looking for, right? The most frequent. So I make it none, I initiate it to none. And then I see, oh, I think I might need to shift this. Alright, if I open character, I make that check in S, right? To make the check. If my most frequent is none, most frequent character is none, and the counts of my character is greater than the counts my most frequent, right? If this is true, if most frequent is none and the count of the character is greater than the count of the most frequent, then the most frequent is equal to the character. So that means that is the most frequent character, right? Most frequent. So basically, I initialize it to none. Oh my goodness. So I'm initializing it to none. And then, so I'm saying that, okay, my most frequent character is what I'm returning, okay? So I'm saying that I do a first check to see the counter and try to see, okay, if my characters are iterate through the characters in the string I'm provided, which it says I can assume that my string is non-empty. So as I iterate through the characters in the string, if the character is not in my counter, I'm making a check saying that the counter of that character is 0, and then I increment it because now I found it, right? So then I'm making a second check to say that, okay, let's assume my most frequent character is none, right? And then I say for each character in S, if that most frequent is none, and the count of that character is greater than the count of my current most frequent, because definitely if most frequent is none, the count of most frequent should be 0, right? The most frequent is equals to the character. So I'm returning most frequent. Let me run it. Is it telling me I'm missing something? I don't know. Did I miss something? Okay, so I missed something. It says for my sources. Okay, for character in S. Oh. So yeah, the indentation is sick, right? Let me see. She said I failed it. It says, oh, so I'm having counter. Gotta watch that. Let's test now. If what? No. What am I doing? For character in S, right? If character not in counter, the counter of the character is 0. And then the counter of character plus equals to 1. Correct? Then my most frequent is none. And I say for character in S, if my most frequent is none, it's not and or the counter of the character is greater than the counter of my most frequent, then most frequent equals to character. And I return there. Let's see. That is crazy, bro. So I missed that because my check was supposed to if most frequent is none, or either is most frequent is none, or the counter character is greater than not end. Alrighty. Alrighty. So that's that. It's very interesting question. Let's see. So this is pair sum. Write a function pair sum that takes in a list and a target sum as arguments. Okay. Write a function pair sum that takes in a list and a target sum as arguments. The function should return a tuple. So a tuple is like braces consisting of the pair of indices whose elements sum to the given target. The indices returned must be unique. Be sure to return the indices, not the elements themselves. That's an interesting question. So it says there's guaranteed to be one such pair that sums up to one target. That's an interesting question. So we are going through this question where, for example, in the first example, we have 3, 5 pair sum. So 3, 2, 5, 4, 1, right? And we are having 3 plus 5 gives us 8. So it wants me to return 0 and 2. One thing that will come to mind is I need to be able to at least keep track of the complementary number, right? Okay, which number, so when I'm summing, which number is a complement, okay? Such that if, for example, I know 3 plus 5 gives me 8, then I keep a track of the index, correct? I keep a track of the number. So I will use enumerate then, because enumerate will give me the index and the number itself. So I need to be able to use something like a form of complement to say that, okay, So a couple things come to mind. So let's say I keep track of the previous number because I already know the index of the first number I'm looking for. All right, so let's say I say the previous num equals to this dictionary. So I can go through and say, because I know that this will give me if I use enumerate, it's going to give me a dictionary, it's going to be a dictionary of the pairs. So I can say that for index comma number in enumerates numbers, right? So enumerate gives me key value pair. Key value pair. Oh man. All right, so I go through this, right? So I go through that. I can say the complementary number, right, is equal to the target sum minus my number. All right, because I know that if I say 3 is my number plus x, in this case, equal to 8, x is the complementary number, something like that. So and x is equal to the target sum minus the number I'm currently on. All right, so then I need to make a check, right? Then so that while I'm needing the previous number is to be able to say the indices returned must be unique. So something must be storing the values are found. If I don't store that in the previous number, then it doesn't have a way of tracking that. Oh, hello, somebody's on the chat. How are you doing? I'm just seeing your chat now. How are you? Oh, sorry. I'm coming. Give me a minute. Let me respond to your chat real quick. I'll come to your chat. Give me a minute. Alrighty. So, complementary number equals to target sum minus num. So, if the complementary number is already in the prev number, which is Maria, I'm making a check. All right. So if the complementary number is in previous number, meaning that it has been found before, right? I need to then return a tuple. So I'm putting that bracket because it's a tuple that I need to return the index, right? And the prev norm complement. All right. If it is in, else I'm returning the previous number, right? Equal to the index I'm looking for. So basically I'm making a check. If the complementary number is in previous number, I return the index, because for it to be there, it means that it is what I'm looking for. Most likely when I keep going through the first one. So for example, this example, so I'm going through, it says for index, so this will be 0 and 3 in the number. So I have my previous number currently empty, and then I'm saying that okay, for 0 and 3 in number, so it does that complementary number is 5 because target sum is 8 that we are looking for. This target sum is 8, so complementary number is target sum minus 3, which is 5, right? So so previous number is empty at this point, so it registers what the complementary number is. So it makes this check. If the complementary number is in previous number, in this case the complementary number is not in previous number, so it jumps here. It doesn't go into this loop, this if statement. It then comes here and then check the previous number of the number is equal to the index, right? It just asks that at that point in time, goes on to the second one, right? And then makes that check until it gets to this 5. When it gets to this 5, it says that if the complementary number is in previous number, by the time it's in 5 now, at that point in time, it's going to know that okay, the complementary number, this 5 now, is in previous number because they would have added it, right? And then return index, comma, the previous number complementary number. So it's gonna return to me the index at that point. At this point is on 2, right? The index of the first one is this index 0, and then this previous number of the complementary number is going to be the index of the second number. Okay, because previous number of number is updating the previous number of the number to be equal to the new index. Alrighty, let's test it and just see what is it saying. No auto detected. Let me see. So it paired it up. It thinks I'm right. Yeah, I think so too, because and then it's open because it has to go through the list. Let me see. Is this guy still responding to me? All right, we go on. All right, write a function pair products, that takes in a list and a target product as arguments. Just the same like what we just did, where we did the pair sum. We're gonna try to also explore using an array, right? It says this should return a tuple containing a pair of indices whose elements multiply to the given target. The indices returned must be unique. Be sure to return the indices, not the element themselves. There's guaranteed to be one such pair whose product is the pair. So we look at something like this now. 3, 2, 5, 4. We know that is only 2 times 4. 2 times 4 is the only thing that gives us 8, right? So it will be requiring us to return 1 and 3 because the index of Python start from 0. And then we go 0, 0, 1, 2, 3, 4, 5 on. Alrighty. I'll be taking a break shortly. I'll be back. I'll be taking a break. All right. And we're back. So pair products. All right, so we need to be able to also just do something like what we did before. Previous number to keep a track of the previous number, right? In such a way that, so let me call that, let me give it an empty array. I'm sorry, an empty dictionary, and then we go from there. Alrighty. So I just like I did in the previous one, which was previous sum. So I say for index, common num, in enumerate, right? Enumerate. We know that enumerate is going to work in such a way that it's going to give us a key value pair of the index as well as the number we are dealing with, right? So I'm gonna go there on the numbers. All right, then the complement in this case, right, equal to the target product divided by the num that we are talking about. So that's the complement in this case, or the complementary number. I can use that just since that's what I used the other time. All right, so that gives us the complementary number, but I need to check, make a check, right? I need to make a check. Am I right in my indentation? So it says, yeah. All right, I know I didn't do the indentation correctly. So I make the check and say if the complementary number is in the previous number that we were dealing with, right? If the complementary number is in the previous number that we are working with, this is just a okay, that makes sense. Then I will return the previous, the index, sorry. Index. I'll return the index as well as the previous number, right? Complementary number to be able to return, because we are told to our output will actually be a tuple containing a pair of indices whose elements multiply. Okay, that makes sense. Okay, of the complementary number, and then I use return, bro, and then I say my previous number. I have to update what my previous number is at this point. So the previous number of the current number is equal to what? The index. The reason why this is, so let's think about it, right? So we are going saying that for index, common number in enumerate numbers, right? Enumerates returns key value pair, right? Enumerate returns key value pair. So basically it returns that is a dictionary, right? That's what it does. It returns a dictionary. So complementary numbers equals to the target number divided by the number, the target product. Here we divide it by the number just to know, because definitely in this case now this is the target product. Now if we are on this number 2, we know that 8 divided by 2 is 4. That tells us that since we have found 2, the next thing we are looking for in the whole array is number 4. And once we see it once, we are good to go. Alright, so it makes the check. That's why we're checking if the complementary number is already in previous number, because there will be cases whereby we could have more than one of that element. Although I think it says be sure to return it, not the element themselves. There is a guarantee to be sure that one such pair would whose product is the target. So there's a guarantee that we'll find one. So we'll just not make a search, an empty search, right? That makes sense. So if the complementary number is in previous number, we have to return the index, comma, prev number. That is the previous number, and then put a complementary number. Like this is giving us the index. We are returning a tuple of the index as well as the index of the complementary number. Yeah, that's what we want to return. We cannot just return the complementary number here to be wrong, because in that case we are not going to be returning our output. So we want to be careful. What is my input? What is my output in your problem statement? Right? We want to be careful. What's our input? What's our output? Alrighty. Let's test this out. It's expected undefined. It tells me there's an issue in my line 6. If the complementary, did I make it? Let me just, okay. This is previous number. Something the oh, my indentation. I don't know. It's my indentation. You have to check indentation correctly with Python. Indentation is very critical. So we have to always be checking the indentation. All right, we move forward. I'm going to try to quickly go straight to, because of my time, I'll check out the questions on this. So I'm like left with 5 on this one, but it's okay because of time. I'm going to go to linked list because I wanted to test some stuff on linked lists and then try some stuff. Hopefully I have time. Okay, there's also graph. Yep, all this I need to pay for them. I just want to test the ones that I don't need to pay anything for, just to refresh. All right, let's go to linked lists. So linked lists.
Module on linked lists. What I have in store is for us to go over some classic linked list algorithms. In particular, I want to show you how to do a basic traversal and show you the iterative as well as recursive flavors of this core algorithm. We're going to solve many different problems that utilize this underlying strategy. So let's jump right in.
Alrighty. Linked lists. So we have A, B, C, D. So a linked list, it has a node. Yeah, time will fail me, but so let's see this real quick. Structy
The term we actually like to use for this is really saying that A's next is
to
B,
B.
right? And the D node goes to the null node, which must mean that I'm at the end of the linked list. So it's a very, very, let's say I have the goal of inserting a new element Q at index 2 of my array. And the key specification that when we insert into an array, that does have an O of n insertion time. We only need to pass a reference to the head node of a linked list.
Alrighty. So let's go through the warm up.
Nodes have no next. Awesome. And a reference to the self as well. Algorithm on. What I'll do to start is just create a node class. So using some Python class syntax, create class node. And in the constructor, or the initialize method, for this class, I just need a single argument. I'll call it the value. If you're familiar with Python classes, you'll always need to take in a reference to the self as well. At this point, I just want to assign this value as a property. This is going to be the stored value within my node. I know that every node is also going to need a next property that points to the next node in the linked list. So I'll do self.next. I'm going to just initialize that to be none. So by default, nodes have no next. Awesome. I'll just create a pretty hard-coded linked list, and that way we can just jump into the algorithm here. And so I'll create a variable called a. I'm going to store inside of it a node. I'm going to give it a value. I can put anything as the value. I'll just use some uppercase already consumed the current node, so now I just need to look at the next node. So I just set current equal to current.next. Right? Then I go to another iteration of this while loop. I keep running this while loop while current is not equal to null. And that'll be the complete implementation for an iterative print list function. Let's go ahead and give this a manual run. You should see all of it. Then I check, is the A. So at this point, my cur is equal to D, and this while means I need a base case and a recursive case. Actual node, I know it. Clear out my terminal. We should get the same output, right?
All right, so wanna print. So write a function linked list values that takes in the head of a linked list. That's an argument. The function should return a list containing all values of the nodes in the linked list. All right, so we go. This is the linked list. So we have node A, B, C. But basically, we want a situation where we can return in the linked lists. Yeah, this is a very interesting one. Alrighty. So it's gonna be returned. The values of the linked list is gonna be returned as an array, right? Just like, okay, let me call it. Yeah, I can return the values as an array, which I'm gonna append. So my current will currently hold the head of the linked list, right? Because you see that the head is the starting point, so this is the head of the linked list, right? So that's the head. I have to make a check on the while loop and say that while my current is not none, because when it gets to this, to the last one, we see A, B, C, and the last one goes to none, right? Or null. So while it is not none, to keep going, so I append the values, right? The append to add it to the list, right? To add the my current value, right? The value currently, I'm gonna add it to these values. So values are current.val, because we see here that self.val, when we initialize the node of the linked list, it has a definition of a function where it is initialized. The constructor is initialized with itself as well as the value, such that the self.value takes that value that is passed in. So in this case, we are going to be adding each of those values into each of the value into values, right? Core values that are pen, and then we have to move forward. What is the new current stuff, right? And say that now my current equal to current dot next. Okay, then what do I want to return? I'm going to return values. Okay. All right, so that returns the values of the linked list. Basically, there's also a recursive way of going about it. The recursion, you need a base case, and then as well as the recursive case, where your base case will be like, so let me try the recursive. I thought that worked though. Okay, I think it's fine. So let me take this, which is what was there, or let me just refresh it and start it again since I passed the first one. So I want to try. All right. Okay. So in this case, the base case will just be it could be where it just has one value or where it has no value, right? As the base case for my recursion. All right. So basically what that implies is, so let's say I have values to be an empty array, right? I can say that for my base case, so I say linked list values, right? Of I'm gonna call linked list value of ed and the values that, because that's gonna be the recursive case, so it's gonna be the function I'll be calling. So I'm giving this my helper function, so this linked list values, and then I'm gonna return values. However, I need to have another function that I'm defining. So this is my helper function, which is the one that will address the base case, I mean the recursive case, right, of ed, and I'm giving it also values, right, that I'm passing into it. I'm making the check for the base case now and saying that if my ed is none, in that case I'm just going to return empty, so return, right. Then I want to add to my values, dot append the ed dot val. So that becomes the new the ed dot val, the values will be returning that to that. Okay, no, I'm gonna return, then come out of the linked list and then say values. Then I'm going to say that I want the recursive case to process what this recursive case is going to now work on just the ed dot next, right, the ed dot next and the values. The recursion is a beast, right? It's very interesting. All right. Let me run it and see. I might make a mistake. So it has this base case. In the base case is when the head is none, it returns just empty, and then values that are append is appending the head of values. I think I prefer the other solution. That's more straightforward. Both of them as often, right? Okay. So refreshing on linked list, right? So we want to go write a function sum list that takes in the head of the linked list. So I'm giving you the head of the linked list, right? And then containing numbers as arguments, the function should return the total sum. So in this case, I'm going to save the total sum to be equal to 0, right? Then I start my stuff by saying the current is currently head. Remember that is that, but I need the head node, so I make a check. Come on now. Why my current is not none, okay? While my current value is not none, to be able to iterate through the whole linked list. All right. So while the current is not known, I'm going to be adding to my total sum current, total sum plus equal to current dot val. All right. So I'm updating my current to be current dot next, right? And basically all I just do is to return the total sum. That give me what I'm looking for, because when it's 2, so if so I'm patterning the head, so because I'm just giving the head node, I say the total sum is equal to 0, right? And then basically all I'm saying is that the current at that point is the head, so the current will be here. So if I have this kind of linked list, right, so it's going to be something like this at the beginning. Let's call it core. All right, so my current is the head is 2, while the current is not known. Okay, what happens? Total sum plus equal to the current dot val. At that time, I add 2 to it, right? I update my current to be equal to current dot next. So at this point, this is current equals to current dot next. At this point, this is currently current dot next, right? So when I'm saying that current equals to current dot next, it brings it here, right? And then it's updating it. Then it goes on again. Since it's not known, it comes back here. Add this, so at that point that added 2, the total sum was 2 then, so you add it to the current, which is 8. Okay, that becomes 10. It does the same thing again, does the same thing again, does the same thing. When it gets to this point now, it still continues. It has to take this 7, but then it makes the check while current is not known, so this is pointing to none. So when it makes the check here, at that time current is none, it comes back and just gives us the total sum. Okay, so let's go on. All right, let's test it. Alrighty. So linked list find is trying to is an interesting one. Write a function, linked list find, that takes in the head of a target, a linked list, the head of a linked list and a target number. The function should return a boolean indicating whether or not the linked list contains the target. Alrighty, this is interesting. All right, this is where I'm gonna round off for the night with this linked list find. Very interesting problem as well. All right, write a function linked list find that takes in the head of a linked list and a target value and should return a boolean. So we want to return a boolean whenever we find the number we are looking for. So we have to make a check to see if the number is found, right? So let's say my current value, my current is currently head, right? And then I make a check. I say while the current is not known. That is why I'm still going through the linked list, right? I'm gonna check and say if the current value, right, is equal to the target, what I'm looking for. That's the target. That's what I'm looking for. If it is equal to the target, I return true. Right? Then update current equals to what? Current.next. Update the current.next. I found what I'm looking for. Else I come out and then all I'm returning is false, right? And I didn't find it. So in this case, if you have A, B, C, D, something like that, let's test it out. Just the logic, right? My current is equal to the head. So in that case, we will just be giving this. So let's say this is the current. All right. While current is not known, it keeps going on. If the current.var equals to the target, so in this case, I'm looking for C. C is my target. It's not. So I keep on going. You know, it's not. I keep going. Oh, B is not. I keep going. When I get to C, C is my target. I return true. You know, now if I get to none and I've checked through all these, I don't find it. That is when I come out and return false, meaning that that target wasn't found at all. The most likely thing is that it will be given. So in a case like this, um yeah, something like this now is false because 100 is not in 42. Yeah, that makes sense. Let's test it. Okay, we are good to go. We'll move on. All right, I'll take another break here. Get node value. All right, write a function get node that takes in the head of a linked list and an index. The function should return the value of the linked list at the specified index. Yeah, let me get a water break. I'll be back. Oh, no, thank you. Alrighty. Write a function get node value. Getting back, having to respond to some quick text. Write a function get node value that takes in the head of a linked list and an index. The function should return the value of the linked list at the specified index. If there's no node at a given index, then return none. So basically, if we are given an index, you want us to return all right, I'll be right back. Alrighty. Alrighty. Let's go on. I want to get the node value. Okay. that takes in the head of the linked list and an index. The function should return the value of the linked list at a specified index. Okay, so let's say the count. So to be able to use the count, okay, equal to 0, and then I say my current is equal to add, and then I say while my current is not, no. If the current is equal to the index, basically trying to say that if my current if my count, sorry, if my count is equal to the index I'm looking for, because at every point I'm going to be incrementing the count, right? If the count at that point, so if I'm on 0 and the count is equal to the index, basically all I need to return is current the value. I mean, I found the value I'm looking for. Now if that's not the case, then the current, I update it to current dot next to go to the next number. Then I update my count as well to say that I'm not in the count yet. Now if I've gone through all that and I didn't still find it, I return none. So how this is operating is, say I take A, B, C, D here, right, and testing this out as my example. So my count at this point, count is equal to 0. Then my current is 8. So my current is 8. The count is 0. Then I'm making a check. While my current is not none, so I've not gotten to the end of the array, or of the linked list. Sorry, I've not got to the end of the linked list, right? So if my count is equal to the index, so it's equal to 0. So if the number I'm looking for, so now it's saying get node A2, right? So A is the head, and then 2 is the, I'm going to get the value that is at the second index, in the, no, at number 2 index, which is now at the third index, because it starts from 0. So 0, 1, 2. Okay, alrighty. So now in this case my current is A, my head, so it says if count is equal to index, return current of val. Okay, but it can't return it now because it's not equal to the index. The index I'm looking for from these is 2. I'm looking for the index, so index is 2. That's what I'm looking for. So what do I do next? I have to move forward on the current, right? So my current moves to current.next, right? My count becomes 1, right? Now in that case, I'm on 1. I make the check again. Current is not none, so I'm not at the end of the loop here. If current equals to the if the count equals to the index, right, 1 is not equals to 2, so I keep going. I'm not returning nothing. I just increase current equal to current.next. That moves. All right, my count becomes 2, right? And then I'm not yet out of the loop, so I go back again. Why current is not none? I've not gotten to the end of the loop of the linked list, and then I'm checking if my count equals to the index. I return current the val. So now 2 is equal to that, right? So I'm returning the current of val, so I'm returning C. In that case, then I don't need to come to update nothing again. I'm done because I just returned C as my response. Okay, all right, let's get it out. Alrighty, let's go. All right, Wow, we are in reverse a linked list in place. We want to reverse a linked list. This is a tricky question. Give me a minute. Alrighty. We go on to reverse a linked list. I'm coming. All right. Um. So I thought the guy was asking a question, but it appears not. Alrighty. We want to reverse a linked list. We take the head of the linked list, right? And then, so basically with reversing a linked list, we take the head of the linked list and, just change the current dot next, like in place, basically. Yeah. So this is it. So something like this is I'm trying to say. Okay, when I reverse this linked list, it turns this tail changes to start focusing on the head, right? So initially this current goes to current dot next, but when I reverse it, so I have to be able to keep track of what was the previous element, the current element, and then the next element. So I'm gonna, it seems my audio is finished. Okay, let me try to get back. Wow, so we've been here for almost 2 hours. Let's go back into the audio. I just want the sound. It helps me focus. All right. So basically that's it. So we're gonna we have to have like a previous element. All right. A previous element that is none. Okay. Then the linked list I'm provided. I still have this as my current. Okay. I still have this as my, no, sorry. This is my next. Right? So I'm gonna say that to be able to do this reverse, I want to point the direction of my current. My next is currently the current dot next. So I want to point it inverse, like the other way, and say I want to point this my current to become previous, and my current, so just inverse it, right? That's what I'm gonna try to do, basically, to reverse it. So let's start by saying that our previous element is equal to none, right? Just as I've done. Okay. And then my current element is the head, just like I always did whenever I was going through all the elements, right? Then I make a case, I make a check, a while loop, to say that while my current is not none, while I've not gotten to the end of the linked list, my next, at the moment, I want to make it current dot next. And the reason why I want to make my current dot next in this case is I've set up my previous to be none. My current is maintaining its position as the head, but I want a situation where my next element is currently current dot next in this position. Then I will now start the inverse, right? To do the inverse, I'm now going to say my current dot next is going to now be pointing. So current, this current, the current dot next, I want to now point it to the previous element. Yeah, it's gonna go, I'm gonna point it backward to the previous element, right? And then I'm going to say the previous element becomes the new current, right? The previous element becomes the new current. Then the current, right? The current becomes next. Sorry, I said current. So basically, this is the current position. I set up the previous to be none, the current to be the head. I make a check. While my current is not none, I've not gotten to the end of my linked list. Now, in that case, I initialize my next pointer to be pointing to become, so next equal to current dot next. Okay? So when next equals to the current dot next, okay? When next equals to current dot next, right? I'm going to now say the current dot next. So this current, I want to redirect it. So this first one, okay, the first move is that it's pointing my next value to the next, right? So that's why I say current next equals to current dot next. So it's to next the one beside the current, right? But then what I'm now trying to now do in this case, at the second move, is that I'm now pushing basically I'm pushing it to the previous element. So when I say current dot next, so I'm saying that this current A, what this means is that I'm saying in this case when it gets to this move, so this is the first position, but when it gets to this move, current dot next becomes previous. So it means that it's going to point this to none. So basically it's going to be doing something like this. That's what I'm trying to do. A, right? Then the previous element becomes the current. So I'm saying in that case, I'm going to move this to become current. That's what that means, right? And then the current becomes next. So this was the previous, sorry. This becomes previous. And then I'm pointing B to now become, sorry, B becomes point backward. So B becomes current. Correct. So B becomes current now. And then the next round goes on. Now, next round goes on. It keeps going on and on. So basically when I finish all that, I'm pointing it back. All will now be something like this. See, it keeps going on. And the next iteration, it keeps going on. D, it keeps going on. E, it keeps going on. F. It keeps going on. But in this case now, so it does all that through the iteration. I'm now going to return. I'm going to return the previous, because in this case now, the previous element will become the new head, right? So when I'm returning previous, it's going to return to me in this format of having it from here, because it keeps pushing. Think of it, it keeps pushing like this. It keeps pushing like this. So when I'm returning previous, at that time, this current is already none. Think about it. It has got it to the end of the reverse. It's already pointing to none, right? And there, when I say return previous, it's now going to return to be subtil of the format FEDCBA. Something of that format. That's what it's going to return to me. Let's test it. Yeah, it's going to return something of that format to me. Oh, yeah. So this is a zipper list, I think. Oh, man. I think I've done that before. Let's try to go to binary tree, where we go to depth first search, and then graph. Man, that's a lot. All right, this way I'm gonna end tonight. Practice makes perfect. Just testing it out. It's quite a lot of questions. We keep trying it and seeing so many nice questions. But I will end it here tonight. Yeah, I'll end it here tonight. Thank you so much if you have stayed with me for these 2 hours. It's just a nice study session. Thank you.